Hello everyone. In this lecture video, we are going to discuss automatic testing and asserts. And the contents that we are going to discuss are testing, the assert statement, and automatic testing. So in coding, you might have executed code to try another input and also change variable or condition in code, then execute it to see what happens. Right? So these are all different ways to test code during development and can be seen as tests to control is the program able to execute from the start to end, or is the program able to handle different kinds of inputs, or are there any kind of hidden errors in the program flow? Does the program works in the way we want it to be? And can my code handle these kind of errors? So testing code is essential to writing code. So however, it is rarely structured done when we are start writing code. So instead, most testings looks like a trial and error. Luckily, these steps from the manual way to trial and error into a more autonomous testing are smaller than one might think. A simple way to do is using the print statement. Here is an example. I have a function which is called find smallest in container. They have a container as input here, and then this function returns the smallest element from the container that I provide as input. So this code here is quite simple. And we can give a container, iterate through it, and find the smallest element. However, even the simplest functions should be tested. For this code, there could be four tests could be tested. For example, what will happen if we have a single element list, or a list, or a set, or a string. So let's write tests for these four one by one using print. For example, here I have done this. Yeah. So the first one, that we can have a single element list. So the resultant expected to by giving the 2 as input to this function called find smallest in container. So let's run it and see. Sorry, I need to run the function as well. Yes. So now we can run again. So yeah, here this test is passed because that's what we give, and then we expect the result is 2 as well. So element list, what will happen with this if I give this list here with elements, and here I could see that my smallest element here is -2, so expected is -2, and then we can pass this input to the function and see what will happen. So that's also passed. The test is passed because I expected -2 and then got -2 as well. And then we can see here testing of a set. So this is the test set we have, and we pass it to the function. And then here it says failed because a set is not subscriptable, and that throws an error. So this is so what we have it here. Set object is not subscriptable. If we have if we pass input as a set because it's not subscriptable, and then like for example, if we have a string here, and then the smallest will be expected a here, and let's see if that's what it gives if I run the function, and yes, it is. So in this simple example, the amount of code is small to write tests. So this code could also be refactored into function taking different arguments in order to help with the different types of testing cases without much problem. However, there are few problems with the print methodology. For example, it clutters the output with a lot of information, and it must be manually removed from the production code if one wants. And unless explicitly stopped on failed test, the reset of the code will continue executing after a, sorry, the rest of the code will continue execution after a failure. And the amount of code can also become a problem as well if we have a code that has many test cases. So hence, I mean, what I mean test cases here, like if we have a bigger code, there we need to write many test cases as well. So hence, a way to get around these limitations by using assert. I don't know if we have remembered, we have discussed also assert statement in error handling and exceptions, but I have it here anyway. So the assert statement can be seen as a condition check that will raise an exception if the condition is false. So the syntax for this assert statement is assert, condition, and expression. So this is the condition is the what needs to be controlled here, and the expression is an optional to provide more information about the assertion. So a common use of assert statement is a sanity check for input and output from the functions. So here I have another example with assert statements. So arithmetic mean, and I have a container. And here I have a assert statement for length container should not be 0. And then I have optional message as well. The container cannot be empty. And then I have, the results is the mean, arithmetic mean of the container that we pass. So here, for example, I test my function. I mean, I call my function by giving this input here, 1, 2, 3. And then I say that assert result equal to 2. The arithmetic mean should be 2 because that's what the mean for this input here. For an input, this one, what we gave here. So this should not be any problem because but what if because here I have a set statement length should not be 0. So now I pass a single empty list here. Then I get an error, assertion error here that the container cannot be empty. Whatever the optional message here. So it gives a little bit more information about the error. So if written well, assertion can be used as a first step to more automated testing process. Now let's see about automatic testing. So code testing should be done as often as possible, preferably after each change made on the code. However, in a manual test, everything can become tedious and more time consuming. Worst, it could be worse if because it is easy to miss one or more tests if one manually mark them off as one go. And if not documented properly, manual tests can also be hard to reproduce. The solution to this is quite forward and intuitive, just to write some more code for that. So always when we are writing code, it is important to reflect upon the purpose of the code first and then dive into writing. So when writing a test, make sure to ask yourself, what am I testing for and why I'm testing these? What different cases are there to test and how many tests do I need to cover all available cases? And what is the smallest possible part I can test in each case? Do I need to set up a certain state before testing a specific case? And also, will this test case interfere with another? So let's see another example So here I have a histogram example. A histogram is a representation of distributing regarding data. It can, for instance, be used to showcase how many times different letters appeared in a string, the given string. So here the code present a naive implementation of a histogram function. The input which is iteratable, and then it returns the histogram, whatever the input that we give. So for a few sample tests can be done for this function. Of course, more can be added as well. So the first test could be the result of a single element test and the result of empty test set, and also the result of string containing multiple characters, and result of tuple containing multiple types, or the result of non-iteratable object. So a simple way to add testing to a module is to place asserts inside this statement here, if name equal to main. So as such, by doing this, the asserts will only be executed and controlled when the module is explicitly evoked as a script and can be imported in any other module or script without evoking the tests. So here I have 4 tests. So this is how you write. So you have this statement as I have mentioned before here, and then have the assert statements for all the 4 for 4 out of 5 here, for 4 test cases here. And then, however, the 5th one, actually, we have a passing non-iteratable object test. So this will raise a type error, something that the statement cannot handle. But there are ways to test these cases as well. So let's see how. Here, the doc test module. The doc test module is integrated directly into a Python language itself. A doc test searches for text that looks like interactive Python sessions. If it's find one, the session is executed exactly as it is, stands to verify that it works exactly as shown. So these pieces of text are commonly placed in the doc string of a module or a function or a class, as hinted by the name of the module. To set up a doc test, simply run the code that you want to test and save the output. For example, I run the example that we have now. So I pass this 0 here, and then when I run this code, then I get this output here. So the error, which is type error, int object is not iteratable, and the file name that I have run the code, my example code, and what is the input I gave. So it's a little bit more information about that. So this could be placed in a doc string for a doc test. But here, if you see here, it's a lot of information, but we don't need all this information to create a doc test, because here this inside code could be different for you and for me, because I have named one function, this function named this, and also I have the error where in my code line 16th, but it could be different in your code. So this doesn't need to be I mean, we can simplify the docs test by not adding these lines here. So this is the simplified version here. Example, for example, you add this in doc string. So here I have example for when I have the same example, create histogram. Then I have added here doc test in doc string. So I hope you have watched the video where we have discussed code documentation and coding conventions, where we have discussed how to create doc string. And yeah, so anyway, here this is the doc string representing our doc test. So yeah, the function name and then the error here. And let's see, to run this doc test, the module with the same name must be first imported. So this is what here I have done. So as I have mentioned earlier, we write the doc states inside this statement here. And then we import the doc test. And then we, so yeah, why we write this one? Because we do not want to force users of the module to be tested indirectly by importing doc test. So from docs test, we need to run the test mode functions to run the doc test. So here is the example that I got. So this is trying and expecting. So this is what we have in the doc string for our function, and also a little bit more information about the test. So just to complete the doc string for the tests we have created using asserts earlier would be like this. So for example, here when you have single element list here, and also this one, what will happen, and also the string as input, and what is expecting results. So, and then also the one that we just have seen, non-iteratable object. So here, as you have seen, docstick module is a big step forward from testing using Assert. However, it has one big drawback. It is all placed in the doc string. So for a smaller test like this one, there is not a problem, but with many tests like this, it can be hard to read the code, and it will start become cluttered with line after line, and as you have seen here, and before it actually reaches the actual code of the function. So for this also, luckily there exists another module for this kind of situation, that's called unit test module. So unit test module was introduced in Python 2.1 and has been integrated part of Python since then. This module is feature rich and contain a lot of tools for constructing and running tests. It is built after object-oriented principles and impose few rules on how a test is to be constructed, but almost any kind of test can be written with the unit test module. So here, the code here below shows how unit test module can be used to create a test for a library function sum. And the line, the line unit test main will execute all the tests found in the code. Here is the example here. We import the unit test, and we have a test case for testing sum function. So here the test case is test case is found from inside the unit test module. And yeah, here this class can be seen as a collection of related tests. One should not mix and match for different objects into one class. Each test is written inside a function, and the function name must be prefixed with test. Here you see that this name should be prefixed with the test. So here we have a test for sum, and then we have input data here as element list here, and then expected result for this is 15, and then we have assert equal statement to compare this expected result and the result we get from this function. And also we have optional message to say a little bit more information, or to give more information to the users. Expected the answer to be 15. And then we have to test the to run a unit test, we need to add this one as well. Main is equal to main, and then the unit test dot main. So when I run, then I get this in this output here. So run one test and it is okay. So this is how we use unit test module. But if changing input data variable in the test to be another one, like removing 0 and 1 in this example here, and without changing expected result variable, the following output will be produced. So because it's not it fails the assert statement, then we get a fail test case. So important note here, make sure that each test written is isolated, and each test are to be assumed to be run either in complete isolation or in an arbitrary order with any other unit test. And never make a test that depends on another test, and also unit test does not guarantee the ordering of the test when executed. So sorry, I have pressed already this link. So in the example, example, we have used assert equal statement for the sum which return 15. However, there are many assert methods that one could use, and it could be found in this link here, as I have opened just now. See here all the assert statements, and based on our test case we can use the one which is suitable. So yeah, more than one assert method can be also called for test case, and each assert method takes a third optional argument, as you have seen as a message. This message will be used as error message if the asserts fails. So there are two more modules. I mean, there are many, but there are two more modules that we can use. For example, if multiple test cases needs the same code to set up the testing ground and clean up after the test is done, then this could be placed in two special methods, or which are set up and tear down. These methods are run before and after each test respectively. For example, I have a theoretical connection is created using a setup method here and closed with the tear down. So for that, I have also import methods for a unit test, and also another one, my socket, where I call some methods to set up the socket and then also close. And here, when I run this example, first it will set up the setup socket. Yeah, and then the test will be executed, this one, and once it's done, then it will be closed and it will be, yeah, whatever be open here, it will be closed. The socket is closed. Yeah, that's what about automatic testing and asserts in Python. And here are the references if you want to look a little more testing in Python. This is very, I really like, they have really good examples and information about Python. And also unit test, you can go in python.org for more information on unit test. Yes, thank you very much for your attention.